Good evening, everyone. I'm Ákos Kapui. I'm CTO of Shaper 3D, and today I'm going to talk about why planning is still a core part of great engineering. There are many companies who already open source their product development process, especially big technology companies talked a lot about how they use planning in their process. They write extensive design documents and then use that in communication. However, small and medium companies don't necessarily have the tool set to use this. I interviewed many people in the last few years, and what was really interesting is that very few engineers could talk about how they use design and architecture discussions early on in the process. They often just dismiss that this is not something that they use or they find valuable in the development. The agenda that we'll have, the only useful part of this slide is that initially I will start with theory. However, in the second part, I will get more to practice and demo at the end. So if you find that the initial part is boring, then hopefully the second part is going to be a lot more interesting for you. And before we get started, just a few words about Shaper 3D. We are a three-dimensional design company. Our product is used by millions of designers and users, and very iconic companies who design and manufacture products using Shaper 3D today. What is interesting is that 16% of global GDP is basically from manufacturing, design and manufacturing, and this whole set of GDP is basically running on a 30 years old of software stack. And Shaper 3D is on a mission to bring this industry to the 21st century. We are building a new product, a completely new philosophy, an impactful, a really big something. Obviously, we are on a journey. We are not yet finished, but this is what we signed up for, and this is what excites us day to day. Whenever I introduce myself, I usually use this phrase that I'm a software engineer by degree and a manager by role. And the reason is that I'm extremely proud to be an engineer. And while talking to fellow engineers and other people, I also see them, they are also proud. And why is that so? 20 years ago, there was this notion of programmer, developer, and gradually this shifted towards engineering. Why are we more using this phrase? What's the difference? What has changed? And I think one of the reasons is that as software products have become more and more complex, they require similar kind of requirements, mindset that exists in other fields in engineering. And if you think of bridge builders, the first bridges were probably built in the ancient Egypt or something, and I'm sure they were not called engineers. At the time, they were just called bridge builders. They used logs and plankets to build some kind of wooden bridge. But as the history has evolved, as these projects, as these bridges has become more and more complex, they required a lot of different philosophies and mindset. So the bridges that we use today are basically not falling apart. So thinking of several different industries like mechanical engineering, civil engineering, and software engineering, what are the common parts of this? Why do we call them in a general phrase engineers? One of the things that comes immediately to my mind is mathematics. So we were forced to study a lot of mathematics. I was not a big fan of that at the time. By the time, it's like good wine. I got to respect that level of understanding of mathematics over time, especially after I joined Shaper 3D. But this is very common across different fields of engineering. They study a lot of mathematics, and very often they use this in day-to-day work as well. The other part is that they use a lot of software nowadays. So many of these processes, development, planning, is that it's supported by software a lot. They use design tools, they use IDE, they use compilers, a lot of different things to create whatever is the end product. And the third one that I would highlight is that they rely significantly on planning and creating blueprints. It's called a plan or schematics in other fields. In software, it's called probably an engineering design or plan. And this is such a fundamental part of the development, often missed and neglected in many companies. But now comes the argument that software is very different. We are not building bridges. Bridges, it's made of concrete. So whenever you make a mistake, you have to delete that concrete. You have to remove that concrete. And while in software, you just typing characters, and whenever you make a mistake, you just have to start again. There is no cost of a mistake. So why would you spend any days, any weeks, any time on creating something that might not be useful at all? You can just try, you can just do it yourself. And in the last 20 years, the agile methodology has become so available and so probably overused as well, is that it made probably planning in many, many companies completely gone. And I argue this was useful, and I think the original way of software development was not high performant and not successful. I think there is a need to have software design part of the process, even if the recent years, even when agile has become the norm. Let's step back a bit and talk about product engineering in general. And I will talk now more of like the terminology we use in Shaper 3D. Before we start, let's specify product for us is not a separate new application. It's any kind of software value. It's an increment, it's a feature. So when I mention product, it doesn't mean that we create something new from scratch. It also might mean that we just extend the feature, we build upon something. We have a single product, so whenever we talk about product engineering, we are extending something that we have built over the years. But we use this phrase of product engineering and not feature development. But those phrases can be completely interchangeable. So product engineering in our philosophy is about turning high ambiguity into clarity, clarity into alignment, alignment into plans, and plans to shipped products. And these phrases are super important, and it highlights the problems of software engineering in general. Whenever you start in the beginning, you just have an idea. You don't know how this feature is going to look like, and you have a lot of different ways solving this problem. You can have hundreds of different ways creating the architecture. The UX could be very, very different from one idea to another. And because you don't know much, and because you don't have necessarily all the information that help you make a good decision, often you end up in a dead end or if in a roadblock, so you have to go backwards in order to build something meaningful. And this was the root cause of why waterfall development was not working out, because that assumed that every single information could be available on paper. You can just define the requirements up front, and then through the development, you can just follow those requirements throughout the whole process. And that's wrong. So let's think about this. You start with a real high ambiguity. You don't know, you just have an idea. You want to solve a customer problem. Maybe a user has requested, maybe a customer has requested something, and then eventually you want to ship a product. The process looks probably very chaotic, but in order to present this on the slide, I have to simplify the whole process. So we ended up with these rectangles. So usually in Shaper 3D, whenever we build something, we sit together with quite a few people in the organization and figure out whether this is something worth pursuing. Is this something we really want to invest in? Because just because there's a user who is vocal about some of the features, it doesn't mean we have to eventually solve that problem, because then it becomes probably a monster over time if we try to react to all different kind of problems. But there are very important insights in customer feedback, and if you can find the ones that matter the most, then probably can build the right features and the right product for the future. So there are a couple of people working together. It might be design, might be the CEO involved, might be the software engineers involved. Usually it's a very cross-disciplinary discussion where people come together and try to figure out what is the customer problem we want to solve. Once this is in agreement, we know who is the customer, we know how does good look like, what is the feature that we are trying to solve as an idea, then it usually moves to engineering design. However, sometimes we even include prototyping. Sometimes we don't know whether this is something that we have as an idea could work for the customer. So what we do early in the process is we create a prototype. So once that is also proven to be useful, maybe after multiple iteration, we move to engineering design and engineering planning. Obviously, this heavily involves many senior engineers because it requires depth of understanding of the software problem. But often QA people are included, often the product managers included, because whatever design we come up with is also influencing what are the product we are going to build eventually. So it's very important to have the right alignment among different functions and people. Sometimes during this process, we realize that the initial plan we have had is just not useful. It might not work out. We assume that we can build it for free or it's very easily, but it turned out that the architecture or the cost of development is extremely high. So we have to refine the plan and go backwards a bit in order to reframe the user problem that we're pursuing. Once this is okay, like we agree that we have a good understanding of how we want this feature to be developed, we should go to the implementation. This is usually the largest part of the software development process. A lot of software engineers are involved, sometimes design is involved. Usually the exact design, the exact UX that we are trying to build out, it's not clear in the initial phases. Throughout the implementation, we gradually move to lower level details, and we figure out the exact specifics of how the feature should behave. Sometimes during the implementation, we also realized that the engineering plan was not great because at the time, we didn't have all the information. We just reduced enough ambiguity to move forward, but sometimes we learn through implementation there is something that we missed. Obviously, we will try to learn from this to make sure that each and every stage we learn the maximum out of the opportunity, but sometimes we do mistakes. Also, in the implementation phase, we often do beta testing. We often release production features to customers, to a subset of customers who we rely on and want to get feedback from. And this depends on feature to feature, but sometimes we collect additional information throughout the development process. At the end, the last part is when we are confident this is the right feature to be developed, right feature to be released, and then this goes to production. Even the release is usually quite complex because first we initially release to a subset of users. We test whether the assumptions that we have had initially is still valid, whether everything is healthy, people are reacting positively, and throughout the course of a week, we gradually increase from 1% to 100% over time, and then basically the whole feature set is available to customers. And obviously, throughout this process, we sometimes learn. Sometimes the bug that users found, something that we couldn't find initially. So sometimes we pause the rollout, sometimes we roll back the feature, and then we start over, fix the things, and then we move forward again with the learnings and the updates we implemented. So the whole process starts with ambiguity, and every single stage, what we want is to remove just enough ambiguity from the process in order to reach a state where we can release a really high-quality product. And while this process looks like really, really complex, sometimes this is done within a month. From starting from the product planning and to the release, it's basically composed and packaged into a 4 weeks development. Not always possible. We have large features that were developed over a course of a year. Obviously, those are usually built up from smaller pieces. It's not a single process, but we try to create the smallest increment that makes sense for the customer. So zooming out, what happens for a single team is that they take on a customer problem, they try to figure out how to best solve them, they implement it, they learn throughout this process, and they ship and use that learning to again feed the information and figure out what to do next. Over time, there are different types of projects. Some of the project doesn't have an engineering plan. It is so obvious and so easy how to ship it that it doesn't require a thoughtful planning. Some of the development doesn't require, for example, in the middle, there is nothing that we should do on the design side because it's just an engineering feature, something that doesn't require many different cross-functional collaboration. What happens, it depends on feature for feature. And if we zoom out, again, for the larger company, there are many teams doing this all day, all night, trying to figure out what to do next, figure out the feature, building the feature, learning from customers, shipping, and then starting again. When I first shared this presentation internally, some of the people said that the way how I describe still sounds like waterfall. Maybe because of the boxes, maybe because I used extensively planning in the process. And if you basically define that waterfall is that where you have design and agile is where you don't, then agree, I think I'm super waterfallish in the development. What I argue is that even though you are not doing waterfall, there's a big value of creating design. And this is maybe just common sense. Maybe it's just use the right tools for the right reason. But in our case, in Shaper, what works really, really well is that we work on iterations. The main concept is that we work in an iterative process. We try to be as incremental as possible. We try to use feedback cycles throughout the whole process, whether it's from users, whether it's from internally from dog fooding, whether it's just sending out certain beta to certain customers. So we always try to validate the assumptions we had in order to remove another level of ambiguity from the process and make making sure that what we end up building is useful and successful for our customers. There's an extreme level of adaptability. Sometimes we completely delete the initial assumption. There were features that we canceled midway because we realized the initial assumption just was wrong. It wasn't worth pursuing because it was just like not good enough. And we started over. And especially the process length is that what matters is that we try to make this process as fast as possible, trying to find the most elegant, simple feature that we can build, and then iteratively refine them over time. So it's very simple. Like the only thing that people have to do now is basically use Agile and then add a flavor of planning in the process. So, and then if they do that, then it's going to be very, very successful. Hooray, that's good, awesome. Well, the problem and my answer is that unfortunately this is not easy. It's not going to be this simple because adding planning and making a good use of planning is extremely hard. And I've seen this in Shaper, I've seen it elsewhere as well, that it always requires a content reinforcement. And one of the reasons it's hard because you can't measure the value. You can't exactly measure why planning was useful. It has to be part of the culture. It has to be part of the DNA. Let's start with some very basic and interesting examples. One of the examples is that John, who is a software engineer in Shaper 3D, and he was tasked to build a new feature. And while he's a senior software engineer, he also doesn't know everything. So he ends up working 2 weeks on creating the final design, something that he feels good about. He started with several different iterations that he discarded, but over time he refined it and then came up with a plan, a documentation of how this feature should behave and should work. So he's sharing this with his fellow engineer, a staff engineer, someone who is really critical about having the right architecture, so we are not burning ourselves later in the process. And obviously there are a couple of problems here. People should not work for 2 weeks alone because it just doesn't work this way. The more you can collaborate early on, the better it is. But the most important part is not around this. Is that whenever you find that a plan, an architecture was just not great quality, it's something that you can have to discard and start over, it feels like this whole work, like the whole work that was spent on engineering design was useless. And I argue because this is probably the most important part of engineering design, because what could have happened if there was no engineering design? Probably you would end up implementing something. And what I learned over years is code behaves like concrete. Remember, in the beginning, I compared bridge to software, and I mentioned that it's really difficult to remove a bridge once it's built. And I think even though code behaves very, very differently, often the case it behaves just like concrete. Whenever you build something, it becomes extremely sticky. There is so many different ways you can remove code, but what happens in practice is that the code that you have written is usually not deleted. What you do is that it's almost there. It's like, even though the architecture that you initially had the idea to implement, it's not perfect. What you do is you try to update the code to look like it could work in the future. And this is the best part, or the worst part, is that whenever you miss the part of planning, what could happen is that you implement code and then you have no plan, no idea, no mood to change this around. So it happens to become a technical debt. So let's move this a bit forward. So there is this poor John who spent already 2 weeks creating a plan, writing a document that was completely discarded, and then he had to start over. So now it's 3 weeks gone, and the project is not moving anywhere. Like as I mentioned, we try to ship things in a month or so. So like 3 weeks gone is like a loss in this already. So the senior product leader is like complaining, is like, how come we allocated this amount of time on this project and we haven't even built a single bit? Like, this is completely not working. And guess who is he talking to? He's going to talk to the CEO. And CEO, even though he's the best CEO, and I think he should be focused on trying to find this inefficiency in the process, what he's going to look, or what we're going to see, is that we spent 3 weeks on creating an unrejected design that didn't have too much value. So immediately what will happen is that engineering design becomes the enemy. Nobody can specifically measure the value of that process because it's just impossible. And what happens, you start to blame someone, start to blame the process, and eventually what happens is that this planning, this engineers who had the idea or have the mood, had the appetite to create great designs, that basically gradually stop doing that, and they just like ship code because nobody can blame the code because that exists, and then at least show some sort of value. So the takeaway I want to do is engineering planning is a very difficult exercise. It's not something that you can just like start doing and then immediately you will be awesome at it. You have to have a process where you learn from this. You start to build small, same with any kind of development. You start to allocate just small enough time to do this and learn whether it was useful or not. And if not, then try to iterate and find what is the best way to improve the use of planning. There is always someone going to try to turn the high ambiguity into clarity, and that work is always difficult. If it's the engineering design that removes the most ambiguity, it's going to be the most painful one. If you skip engineering design, probably there's going to be something else in production development where there's still the ambiguity, so it has to be removed. But the more you delay, the more you defer to later stages, it will become more like waterfall. And the later in the process you figure out any of these learnings, the worse it will become and more painful it will become. Your engineering culture matters here a lot, and then I think the engineering culture is about how you communicate, how you make decisions. If you think about an idea and how you turn into clarity into plans into alignment, and then to ship products, it's basically all about communication and decision making. So this is what defines your company, and this is how you could end up building high quality products faster, or the other way around, low quality products slower. And it really matters how you think about this whole process over time. So that was the theory and more like slide-ish presentation. Now I go into a bit of a demo for now. So as I mentioned that we take engineering design seriously, that means that what we have is that most of the teams are asked to do engineering design wherever they feel it can create value. Usually the thumb rule is that if you build a project for a month, so like you spend months of development time, it's probably worth to have a few days of thinking. Maybe it's a whiteboarding, maybe it's a documentation, maybe something that, what I will show now, like creating a document. But not doing any kind of planning is usually something that we advocate not to do. So one of the features that was very recent, as you can see, this was created, the whole plan was created, updated in October. So the owner of this project is István, who is an engineer in one of the teams. There are actually two teams who were involved in this process. One of them is called collaboration and the other of them is called sync. And if you think of review the actual history of this document, what will show you that end-to-end, it took from September 26th to October 14th, the whole engineering design, and maybe the development as well. But it's a lot of time. But if you look into the details, what you will see is that the version 1 was just created, it was just a placeholder. David, who is the engineering manager for this team, created the placeholder document as soon as the task was identified. Then it was assigned to István, who worked basically 3 days on the document. And this included a lot of collaboration. Even though what you can see in this page is that he's editing a document, what happened in reality is there has been a lot of discussion in person, a lot of whiteboarding, a lot of different parts that was figured offline before the documentation was edited. So after a couple of days, 3 days of work, this document was shared with a lot of different people. And then several other people contributed to the document until it reached a state where we felt like this is already good enough. The development was already ongoing, probably not late after the 7th of October. So there was also a lot of parallel activity doing. So we ended up building something parallel while the design was still ongoing. Let me go back to the original document. So what you can also see here that there are a couple of people who were assigned to the reviewer, similar how we do code review, where there's a reviewer. We do the same thing for any engineering design. Is like we identify upfront who are the people who should be involved, and we add them to the document. They are immediately notified whenever we start crafting a document, and they usually observe or participate heavily as well during the collaboration. Peter was also part of the team. I think he's also accepted. It's just like forget to mark as complete. We don't necessarily want a full acceptance across the team, but it's important to signal how people feel about the quality of the document. Is it good enough for us to start the development? One individual I want to highlight is Victor. Victor is a security engineer at Shaper 3D. He's not part of any of these teams. However, because we are working on a commenting feature, it requires authentication. It handles a lot of critical sensitive information. So it is important as well to involve security, making sure that the data that we persist and transmit is going to be secure as well. Usually this document starts with a design goal. It basically describes of what the goal of this document. This document aims to uncover the details of introducing the commenting feature for the web viewer on the backend. We mainly focus on receiving, storing, and serving comments that include the user input as well as metadata for placing the comments. So this is basically just setting the context. And then there is a lot of different parts. The theory of operation is basically describing how we imagine this feature to work. This is probably the high-level definition of the architecture. Usually there is a lot of potatoes and arrows also done just to make sure that people can easily process the information. If you go lower, what you can see is also that often when we deal with databases, when we include some sort of database chart explaining how different parts of data is going to be connected and stored. And as I mentioned in the beginning, there is security included as well. For example, we are going to introduce this to customers who take commenting and security very, very seriously. And what we need to deal with is like how we are going to encrypt the information. So it's important that we have a clear understanding how this is going to fit into a larger piece of enterprise customer deployment as well. And then there is this actual like table definition. These are things that we probably have to define anyway, so this have to be written by someone. But what we do often is that we pull this ahead, so we are discussing and reviewing like table structure upfront and not late in the process. If there was anyone who dealt with real-time, like upgrading or migrating data from one database structure to another while without having any outage or downtime, then probably can understand why this is important for us. And one of the things I wanted to show is an interesting one. There has been a lot of comments around the table, but the more important one is a comment from Peter. Peter is working in the rendering team, and why would someone from the rendering team comment on a commenting feature on the web? And the reason for that is that we are storing three-dimensional comments, so like we attach this to the 3D geometry, and it's absolutely important how we are going to persist this information that's going to be accurate. And Peter is one of the individuals who have a really, really good understanding of this, while probably the web viewer team, the team that works on this feature does not necessarily have. And what this single comment, like single precision is plenty for position, normal, and camera data, basically triggered a lot of additional discussion of how to best store the information. And we ended up changing a lot of the database structure that we initially implemented. At the end, there are some APIs also defined, so there are a lot of different things, and also usually we put together a list of tasks. Unfortunately, time is also here. There's a lot of updates, but basically the work started in October when the tickets were created, and the feature was shipped in early December. So overall, the whole project was around 6 weeks. And in production now, this is already available. So the demo that I'm doing now is basically available to customers, and the whole plan was just figured and laid out a few weeks ago. So there is this 3D design, and you can pan around in a 3D object, and you can add different type of comments to the geometry. Oops, I zoomed in a bit too much. And if I want to add a new comment, I can select the tool, and I can put to the geometry and then here and send it as well. Now, different users who are also accessing data can review the comment in the proper position. Closing of the demo is I want to just circle back that a document that we created was read eventually by 23 people, and it's quite common that some of the design that we do is read by 30, 35 people. A company consists of around 60 people in engineering, and usually half of them read engineering designs. Obviously not the same half every time, but depending on what is related to their domain. And we find it tremendously useful to allocate a few days of work on engineering design so we can benefit from that learning and that interaction over time, and we don't build something that we are not comfortable with. I hope this was exciting and useful, and thank you for your attention.